Okay, so we classify separable equations a certain way. So normally you would say dy dx equals f of x comma y. Okay, so when we're talking about separable equations, we're going to split that f of xy up into two parts. One of them is going to be g of x, which is only dependent upon x. And then the other part we're going to call k of y, which is only dependent upon y. So if you want to talk about them as a product of two functions, each only dependent upon a single variable, we call them g and k. All right, so f is a multi-valued function. Okay, not every multivariable function can be written as the product of single variable functions. Does everyone understand what I mean when I say that like f of xy is a multivariable function and then g of x and k of y is a product of single variable functions? Do I need to explain that more, or just do those words make sense? Alright, cool. Now, sometimes you don't want to, if you want it to be separable, yes, there are multivariable functions which cannot be written as the product of single variable functions, in which case that differential equation would not be separable. This is what, you have to be able to do this. You have to be able to separate them into two separate functions to make it separable. Cool. Sometimes we also like to write it as the quotient of two different functions, single variable functions, in which case we call it g of x, and then we say that it is divided by h of y. Okay, so remember this is dy equals dx. dy equals dx. Now we're gonna take this over here. Notice that what you can do is you can divide both sides by g of x. Wait, I'm sorry. I don't want to do that. You can divide both sides by k of y. And then multiply both sides by dx. Okay, the ky's cancel, the dx's cancel, and what are you left with? You're left with h of y times dy. Notice that h of y is the same thing, right? 1 over ky is the same thing as hy, equals g of x dx, and they have been separated. Right? H of y is the same thing as 1 over k of y. Now, there's actually, you have to put a caveat on this. What is the caveat for this actually being solvable? Yeah, exactly. K of y can't be equal to 0. So you have this like assumption, and sometimes you have to go back and look at what you've done to see if you've implicitly, if your k of y function is ever equal to 0. That will rule out particular solutions, basically, and we'll look at an example of this in a moment. But hopefully it's making sense to everyone that, like, yeah, you know, in particular cases it won't work. If we go back and go up here, Actually, let's just write it down. No point in doing this. For our previous example, we had dy dx equals minus 6xy. So you could say that our f of x was equal to minus 6x, in which case our k of y is equal to y. Is it possible that y is equal to 0? Yes. K of y equals y, so k of y can be equal to 0, right? So you don't ever get any solutions where y equals 0. And why does this make sense? Why can't you ever have a solution where y equals 0 for this equation? What was the solution for it? Do we remember? So according to this, my y cannot be equal to 0. What was the solution for that differential equation, and why does this make sense? Yeah, e to the x can never be equal to 0. Our particular solution was, or our general solution was y of x equals a e to the minus 3x squared, right? E to the anything can never be equal to 0, right? You have a horizontal asymptote at 0, and you can see that in the vector plot. Remember, you have that horizontal line at y equals 0. You never get a solution that passes through there. Remember how we talked about that being like the boundary between the different solutions? So this gives you a quick way of what you need to check to see for ruling out particular solutions. Yeah, making sense? Questions on that idea? I'm going to sit back. Because I said right here that g of x times k of y is the same thing as g of x divided by h of y. So in other words, h of y has to be equal to 1 over k. You can either write it as a product or as a quotient. And you can't have k of y equal to 0 because you're dividing both sides by k of y. But hopefully it's making sense as to why your solution can't be equal to, why y can't be equal to 0 for that one. Why k of y can't be 0. Okay.